Dr. Elena Rodriguez stepped out of the atmospheric processor module, her boots crunching against the rust-colored regolith of Kepler 442b. The oxygen readings on her environmental suit displayed a steady 18.2%, barely breathable, but sustainable for the terraforming crews who have been working this world for the past 3 years. What concerned her wasn't the thin atmosphere, but the data streaming across her tablet's display. The iron oxide concentrations are off the charts, she muttered into her comm unit, watching as another dust storm approached from the eastern highlands. Marcus, are you seeing these mineral absorption rates? Through the static, her research partner's voice crackled back. Copy that, Elena. The preliminary soil samples are showing something we didn't anticipate. The indigenous microorganisms aren't just surviving our terraforming efforts, they're actively fighting them. Elena knelt beside one of the massive atmospheric converters, its cylindrical form humming with the effort of transforming the planet's carbon dioxide-rich atmosphere into something resembling Earth's composition. But around its base, she noticed something peculiar. The metallic surface showed signs of corrosion far beyond what their models had predicted. More troubling still, the corrosion pattern seemed almost intentional. She collected a sample of the rust-red substance coating the machine's exterior and fed it into her portable analyzer. The results made her stomach drop. The corrosion wasn't random oxidation, it was the product of highly organized bacterial colonies, working in concert to break down the terraforming equipment at the molecular level. Marcus, we have a problem, she said, her voice tight with concern. The planet's fighting back. 3 hours later, Elena stood in a climate-controlled environment of Base Station Alpha, surrounded by holographic displays showing the planet's atmospheric composition over the past 18 months. The data told a story that challenged everything they thought they knew about planetary engineering. Look at this pattern, she said, pointing to a series of fluctuating graphs. Every time we increase oxygen production, the indigenous bacteria respond by accelerating their iron oxidation processes. They're not just consuming our equipment, they're using it to create massive rust storms that strip oxygen molecules from the atmosphere. Commander James Mitchell, the mission's military liaison, leaned forward in his chair. Are you telling me this planet has an immune system? In a manner of speaking, yes, Elena replied. Kepler 442b has evolved a complex ecosystem of extremophile organisms that maintain atmospheric equilibrium. Our terraforming efforts represent a massive disruption to that balance, and the planet's biosphere is responding defensively. The implications were staggering. For decades, humanity had approached terraforming with the assumption that they could simply impose Earth-like conditions on other worlds. But Kepler 442b was demonstrating that planetary ecosystems were far more sophisticated than anyone had imagined. Dr. Lisa Thompson, the mission's xenobiologist, pulled up a three-dimensional model of the bacterial colonies they had discovered. These organisms don't just exist randomly in the soil. They form vast networks, communicating through chemical signals across hundreds of kilometers. It's like a planetary nervous system. Elena studied the swirling patterns in the hologram, recognizing something that made her breath catch. They're learning, she whispered. Each time we modify our terraforming approach, they adapt faster. The response time is decreasing exponentially. Over the following weeks, the team made a revolutionary decision. Instead of fighting the planet's natural systems, they began working with them. By introducing carefully designed hybrid organisms, part Earth bacteria, part native microbes, they created a symbiotic terraforming process that satisfied both ecosystems. The breakthrough came when Elena realized that successful planetary colonization wasn't about conquest, but about integration. Kepler 442b taught humanity its first lesson in cosmic humility. Planets weren't empty canvases waiting for human artistry, but living systems that demanded respect and cooperation. As she watched the hybrid organisms slowly transform the atmosphere while maintaining the planet's natural balance, Elena understood that they hadn't just terraformed a world, they had learned to terraform themselves, adapting human ambition to cosmic reality.